Hello, my name is Avi Kantha, and today I'll be presenting my final project for CS 2216, Data Input and Manipulation. So the point of interest and the purpose of my project is that the hypothesis entails whether there's a correlation between the weather and the air quality, which in this project I delved into specifically CO emissions on a given day in Los Angeles in 2023. And weather changes affect human activity, so the question also entails how does human activity affect the air quality? And I chose this topic because the weather is important to human survival in the future, and I want to raise awareness by helping educate people on how we as humans are adversely affecting the weather. I expect to find worse air quality during extreme weather conditions where human use of fossil fuels will increase. So for my data collection process it was hard. I had to scour the internet. It took a bunch of time to find my data sets. Um, So for the first two data sets, I looked at government websites for specifically the weather and the air quality emissions, and then for the last website, I looked at a bunch of APIs to try to find a specific one relating to the project or something I could work with. And I also looked through all the different government websites that the professor provided for this project. So for the first data set, to clean it, it had many lines of code. It ranged from all different counties in California. So I had to narrow it down to just Los Angeles. So I did that, and then I removed rows containing NANs, and then I converted all the dates to the datetime format because it was as the string format earlier, and then I selected all my relevant columns for use, which with my the location, then um, the carbon oxide, the COs, and then I found the mean CO value for each day in LA location because there are many different Los Angeles locations that all had different CO values, and so I had to look through all of them, find the mean, and then um, group it via date, and then I saved the clean data into a CSV file. For the second data set, I parsed through all the HTML and selected tables. I extracted the date and converted it to match the data format from data set one. And this was a little bit more harder to do because of how the date itself was set. So it took a little bit of parsing. And then I filtered out any unnecessary rows that were in the actual HTML because I didn't want like any header rows and etc. And I extracted all the relevant information, the date, the high temperature, low temperature, and the precipitation, and put it in a dictionary. And then I converted it to a pandas data frame and exported it into a CSV file. And for the very last data set, I requested the API using the access key that I was given. I had to create an account and parse the JSON. And then I extracted the carbon dioxide value for today from the JSON, and then I checked whether there was a value extracted so that I wasn't hit with an error. And if there was, then I converted it from UG3 over M cubed to the ppm to match the very first dataset CO units because these two were different. And then I also exported it into a CSV file. So my first insight, I decided that I wanted to check how the CO levels differed, the mean CO levels differed per month. So the way I did it is uh, I looked at the very first data set and then made a copy, and then I extracted the date and month. And in the month, I decided to group it by months and then find the average CO value, and then that gave me this table to the right. For the second insight, I wanted to, based on how the weather was, whether it was pretty hot outside or pretty cold outside, or whether it was moderate outside, I wanted to figure out whether um, the CO value changes between that. So obviously, I parsed through the first two things, and I joined the two data sets, and then from there I made my own little um, lines for what is considered hot, what is considered cold, and what is considered moderate um, in Los Angeles, based on the yearly data, and then I grouped all the carbon oxides based on whether it's hot, cold, or moderate, and then and and then I grouped it by that, and then I put it in a table, which you can see on the right. For my third insight, I just wanted to compare today's CO value to the CO value from the previous date, just to see how what the differences are and how humans the way they create emissions changes day by day. So I looked at Third Insight. I did all this in the right way. I parsed through it. I created my month days, and then I had to for today's date, I had to match it to a 2023 date, and I found both of the CO values, and then I put it into a table. For my fourth insight, there's a bunch of things here. I just wanted to find all like relevant data with the COs. So the main thing that I wanted to actually do with this one was find the highest CO and then the lowest CO, and then just some statistics regarding that. What the high temperature was, the low temperature was, how was the precipitation, and then I noticed that in December you had the highest CO day, and then May you had the lowest CO day, which was around the cold months for the highest and the hot months during the lowest, which I expected. And then I also decided to find the average COs so that I can compare it to the high and low and see how big of a margin there is. And then I found all the important uh, things for the box and whisker plot, so I could use it in a, which is just so you can see like what the low, the first quartile, the median, third quartile, the maximum looks like, which I will be using in a visualization later. And for my very last insight, I wanted to check uh, what's the difference in the CO levels with precipitation and without precipitation. So I once again merged the data sets, and then I created a another function inside to check whether it's raining or if it rained during that day or if it did not rain during that day. If it rained during that day, I'm grouping all the COs together, finding the mean of that, and then same thing for without precipitation, and then I'm putting it in a chart, which you can see to the right. As you can see, the without precipitation has a higher ppm, which I I assume is due to the fact that during rainy days human activity decreases, and hence dropping the CO level, average CO levels. So for my first visual, I decided to create a line chart for the the monthly average CO levels, so we can really see how it changes per month, and we can see like it starts off high in January during the winter months, and as it goes into the middle of the year during summer, it goes lower, and then as it turns winter around September again, it starts skyrocketing up until the 0.6, 0.7 range. So it really highlights the differences and the changes throughout the year. For the second visual, I wanted to create a box and whisker plot so I could see, any potential outliers in the CO values, and I wanted to see how the spread of the actual data looked like. And so, if you look at the box and whisker plot, you see the more likely outlier at the max, and you can see that like while the spread is it's very compact down in the minimum area. Whenever it does get very high, it gets pretty high, and from the medium to the third quartile is bigger than the median to the first quartile, which is very significant when it comes to the human activity and how it increases this. And for the third visual, I just wanted to create a little bar chart so you can see the how the average CO value is based on the weather type, whether it's hot, cold, or moderate. And when there's more extreme conditions like hot, cold, and hot, there seemed to be a higher CO value, especially when cold, because I'm assuming with all the heating stuff, with, creating fires to they were burning a lot of things, and it's also like wintertime. The cars and stuff they use more gas, which increases the CO level in the air. Yeah, and then for the conclusion, so some big challenges of the project involve finding the data sets, trying to clean the second data set, and trying to figure out how to format Insight 4 to make it look visually appealing, because I was trying to put it in a data frame, and it was kind of hard to make it look visually appealing. But then through this project, I learned many new things, including creating a Boston with scriptplot and matplotlib, and learning about the quantile functions in pandas and more. which I thought was really nice, and I think I could use it in the future a lot. And then the results did support my hypothesis. I gathered many different insights to the data I hadn't thought of until I cleaned it. So the extreme weather did support my hypothesis that there would be a worse hair quality. And then some improvements that in this project that I would make are I would widen the scope of the project, find some better data sets to have more to analyze, more data to analyze, and then expand the scope of the question to detail other intricate things related to air quality and weather so I can draw more conclusions and create more insights. Thank you for listening to my presentation.